friends, welcome back to this video. In this video I shall explain this subtopic under acids, bases and salts, which is called qualitative analysis. Now this topic some time back used to be a practical topic, but now it's usually asked in theory. So just go through an overview of how this qualitative analysis table works and how the questions will be phrased, and probably in the next video we shall look at how to tackle questions underlying this qualitative analysis. This is the last section under acids, bases and salts. So now, qualitative analysis is a branch of chemistry which deals with analyzing or finding out what a substance is made of. Uh, 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 when you're dealing with chemistry, you have quantity and uh, it can be uh, quantity, or how do I put it? Or what a substance is made of. That is what qualitative analysis deals with, in terms of how is the color, not really looking at the mass amount of amount that is in a substance. We're just trying to find out what is contained in the substance by looking at the color, maybe producing bubbles and so on. So we have what are called ions and cations, anions and cations, when dealing with this qualitative analysis. And so you understand that anions are negatively charged type of ions. And so depending on what type of anion you have, you expect different results on the qualitative analysis table. For example, a substance that is made of carbonate as the anion can be tested using dilute acid. So you can have sulfuric acid, hydrochloric acid, but usually the acids that we use here are strong acids. So this does not come alone, the carbonate. It usually comes combined with something. For example, calcium carbonate, sodium carbonate. So because we have a carbonate there, the carbonate can be tested using dilute sulfuric acid by adding bit and drops of it. So what do you observe after this? What you usually observe will be an effervescence, or bubbles will start to be produced, and that will tell you that okay, a carbonate is likely to be present in this compound because there's an effervescence. Remember that an effervescence is not only for carbonates, it can also form for other substances, but particularly here we are talking of adding a dilute acid and producing an effervescence, right? So that's the first test. Then we have a chloride. So as well, this one has to be combined to a substance when you're testing it. Then you add acidify with dilute nitric acid, then add aqueous silver nitrate. So the reason why we're adding this dilute nitric acid is just to acidify it, and then we now use silver nitrate to test if a chlorine ion is present in the sample. And what will form will be a white precipitate. A precipitate is a solid, and you understand that why we are forming this white precipitate is because when this silver nitrate here is reacted with chlorine ions, you form what is called silver chloride. And we learned in under salts to say silver chloride is an insoluble salt, and anything that is insoluble will form a solid. So in this case, you are forming a white solid, which is a white precipitate. PPT means precipitate, and the precipitate is always a solid. So that is how you can basically test for the anion, chlorine ion. Then apart from that, we have iodine ion, which can also be tested by starting first with acidifying it with nitric acid. To understand that this is also a halogen, so that is why we are first acidifying it, and then adding silver nitrate as well. So the test for these halogens is basically the same. What is different is in the color of the precipitate formed. In the case of iodine, we are forming a yellow precipitate or solid. Moving on to the next one, we have nitrate ion. Nitrate ion can be tested by first adding aqueous sodium hydroxide, then aluminium foil. Then after adding these two substances, you warm it carefully. Then what will be the results if this nitrate is present? You have ammonia gas forming because you have nitrate, which basically looks like pretty much like ammonia gas. So you form ammonia gas, which is NH3, and then that will show you that of course here you've produced what? You have a nitrate present in the sample. Finally, on the anions, we have sulfate ion. We start off by adding a dilute nitric acid, and then in this case we now add barium nitrate. Barium nitrate will form a white precipitate. Why? The reason will be the same as for silver nitrate, because sulfate is a very insoluble salt and will form a solid or a precipitate when reacted with a soluble substance like this. So expect that you have a white precipitate. Moving on to cation ions. Cation ions are positively charged ions. Usually they are metals. So we start off with the first metal, which is aluminium ion. Aluminium, um, um, when we're testing this, we use two substances. We use either sodium hydroxide or ammonia gas. So you understand that when we are testing for ammonium, we cannot use ammonia gas because they are basically the same. Not really the same, but we don't use ammonia. So for aluminium, if you add sodium hydroxide, it will form a white PPT, white precipitate, which will be soluble in excess, giving a colorless solution. So if it's present, this aluminium, you have a white precipitate. And if you add excess of this sodium hydroxide, it will dissolve, then it will give a colorless solution. Then what of when we are testing using ammonia? It will also form a white precipitate. But in this case, they do not tell us what happens when you add excess of this ammonia. And then for ammonium, we test by also adding sodium hydroxide. We don't test using this other one, which is ammonium. So please note that for cations, we only use two substances to test for it, which is sodium hydroxide and ammonia. Yeah. So for this ammonium here, if we add sodium hydroxide, it will produce ammonia gas. And then that will show you that, okay, ammonium ion here was present. Then we have calcium. Calcium will also be tested using the same. So you can see here notably say here for cations, we only have two substances to find out if it's present. But when we are looking at anions, we have different substances with different ions. So for calcium, when bubbled through sodium hydroxide, it will form a white precipitate. But if you add this sodium hydroxide in excess, in the case of calcium 2 ion, there will be no, it will not be soluble. It's not soluble in excess. Then when you test it using ammonia, there's nothing that happens. There's no precipitate. Moving on to copper 2. Copper 2, when tested using this sodium hydroxide, will turn a light blue precipitate and then it will be insoluble in excess. Then when tested using ammonia, it will be light blue. Also, it can be dark blue. Then we have ion 2 and ion 3. Ion 2 forms a green precipitate, while ion 3 forms a red-brown precipitate. So these two, both of them will be insoluble when you add this sodium hydroxide in excess. And then when you are testing them using ammonia, it will turn green precipitate and brown precipitate here, which are basically the same colors here. Moving on to the last two, which is lead 2 and zinc. Lead 2 forms a white precipitate. Zinc forms a white precipitate as well. Lead 2 is soluble in excess. This is also soluble in excess. Then they also give a colorless solution. So where is the distinction? The distinction is here when you're testing using ammonia. When you're testing using ammonia, lead will turn white precipitate. This will also be a 10 white precipitate, but this one will turn colorless in excess in case of the zinc. So basically that's the qualitative analysis table, and I hope you found this video helpful. So in the next video I shall be explaining how you can use this concept to answer past exam questions or any other type of questions related to qualitative analysis. Thank you.